Hello everyone, welcome to the turning point. In this session, let us learn Parallelogram Law of Forces. Before going to learn that, first let us see how to find resultant for two vectors when they are having same line of action. So here I am considering here two forces P and Q. If I want to find the resultant here, so I can find the resultant by means of algebraic summation of these forces. So here when I consider algebraic summation or vector summation or vector addition, so I need to consider the direction as well as the magnitude. So P is the magnitude of this force and it is along positive x direction. So here Q is the magnitude of the second force and it is also along positive x direction. So then I can say that the resultant will be equal to P plus Q and it is also along positive x direction. Suppose if I consider one force P in this direction and another force along same line of action in the opposite direction. Suppose if I consider P is the largest force here, so when I consider the resultant, so there I have to perform vector addition. So as P is in this direction, Q is in this direction, so there I need to consider P minus Q. And the direction of resultant will be in the direction of larger force. Here I am considering P is the direction of resultant. So the direction of resultant is like this. As the direction of larger force is in this direction of resultant will be also in this direction. So when two forces are collinear, so that means if they are having same line of action, so it is quite easy to calculate the resultant. What happens in the case, suppose if one force P is like this, another force Q is like this, and both are at an inclination of theta with each other here like this. In such case, how to find resultant? Which method you need to use for that? You can use Parallelogram Law of Forces. First, let us see the statement. Parallelogram Law of Forces states that if two forces are acting as the adjacent sides of a parallelogram, then the diagonal passing through the intersection of those two forces will represent the resultant both in magnitude and direction. In order to derive the relation for resultant magnitude and direction, so I am considering two forces here. Let P be one of the force acting in this direction and Q be another force here acting in this direction, and just theta be the angle between those two forces. One force Q is in this direction and that force P is in this direction. So I have to find the resultant for these two forces. As per the statement, if two forces are acting as the adjacent sides of a parallelogram, so how these are? These are as the adjacent sides of a parallelogram, right? So then the diagonal passing through the intersection of these two forces. So in order to consider the diagonal, first I have to construct the parallelogram, right? So from the properties of parallelogram, opposite sides are equal and parallel to each other. Suppose if this magnitude is P, so then I have to consider a force which is of same magnitude P in the same direction. So P is like this, and I have to consider Q such that, so it should be parallel to Q, it should be parallel to Q, and if it is making an inclination of theta with horizontal, so this one should also make inclination of theta with horizontal. If this is P, this is P. If this is Q, this is also Q, right? So I have constructed parallelogram. So now as per the statement, if two forces are acting as the adjacent sides of parallelogram, then the diagonal passing through intersection of those two forces. So now I am going to consider the diagonal there. So this is the diagonal. Then the diagonal passing through the intersection of those two forces will represent the resultant both in magnitude and direction. So that means this will be the resultant, and if these two forces are acting away from the point, so then the resultant will be also directed away from the point. So in order to derive the relation between the resultant magnitude and these two forces, what I am doing here is, so first I am naming the parallelogram. So let us consider this point as origin O, and this point as A, and this point as B, this point as C. So OA BC is the parallelogram now. Okay, I am extending OA. So this is horizontal one, I am extending here, and I am dropping a vertical from point B. Now if you observe here, the intersection of these 2 points, I will consider that one as D. At D we are having right angle, right? At D we are having right angle. So now if you observe ABD, which is nothing but a right angle triangle here. So this is A, this is D, this is B, right? And this is Q, and it is making an inclination of theta. From the concept of resolution, okay, or otherwise if you consider cos theta from this one, cos theta is nothing but adjacent side by hypotenuse. So adjacent side is AD, right? Hypotenuse is Q. Hypotenuse is AB, which is nothing but Q. From that, AD is equal to Q cos theta. Okay. So just I want to find the value of BD. So for that purpose I am considering sin theta. Sin theta is nothing but opposite side divided by hypotenuse. Opposite side is BD. Hypotenuse is nothing but AB. So instead of that I can consider Q here. So BD divided by Q. From that, BD is equal to Q sin theta. Right. So that means AD value is, this one is Q cos theta and BD value is Q sin theta. Now I am redrawing the triangle once again. So I am drawing the triangle OBD. So when you consider triangle OBD, so it is a right angle triangle. So this is O, this is B, this is D. It is right angle here, and the distance from O to B is nothing but resultant, and OD is nothing but OA plus AD. From the parallelogram here you can observe there OD is nothing but OA plus AD. So we know that OA is nothing but P here, and AD already you have calculated here. So which is nothing but Q cos theta. So from that, this is nothing but P plus Q cos theta. And next, the distance BD. So we got that one as Q sin theta. So here I would like to find the relation between resultant and the two forces, and resultant is a force, right? So I need to find the magnitude as well as direction. Let us consider resultant is making an inclination of alpha with horizontal or force P. So I have considered like that. So as I want to establish relationship between these two forces and resultant, so I am considering Pythagoras theorem. From Pythagoras theorem, hypotenuse square is equal to side square plus side square. So that means hypotenuse is r square is equal to, so one of the side is P plus Q cos theta whole square, plus another side is Q sin theta whole square. From that I can write r square is equal to, so this is in the form of a plus b whole square, which is nothing but a square plus b square plus 2ab. From that, which is nothing but p square plus q square cos square theta plus 2pq cos theta plus q square sin square theta. So taking q square as common, so it is sin square theta plus cos square theta plus 2pq cos theta. So this is the value of r square. So if I simplify it further, so r square is equal to p square plus, we know that sin square theta plus cos square theta value is 1. So it is q square into 1 plus 2pq cos theta. So this is for r square. Just I want to find the value of resultant. So r is equal to square root of p square plus q square plus 2pq cos theta. So this is the relation for resultant magnitude. So if you want to find resultant magnitude, you can use this relation. What about finding direction of resultant, you may ask. So from the same triangle I can find the direction of resultant. So in order to find the direction, which is nothing but alpha, first I will consider tan alpha from this one. So tan alpha is equal to, here the opposite side is q sin theta and adjacent side is p plus q cos theta. From that I can find the value of alpha. which is nothing but alpha is equal to tan inverse of q sin theta divided by p plus q cos theta. So this is the relation for direction of resultant, and this is the relation for resultant magnitude. You can use this method when there are two forces and when there is a necessity of finding the resultant for those two forces, and if there is 3 or 4 forces, then also you can apply this method. But it is laborious when there are more number of forces. If you want to solve this by this method, you can solve it, but it is laborious. It will take time. It is convenient to use this method when there are only two forces. Hope you are able to understand the relation between resultant magnitude and resultant direction. If you are able to understand this relation, just click on the like button and don't forget to subscribe. Thank you for watching.